Everyone, so I hope everybody is clear with what is the machine cycle. If it is not clear, then please comment in the previous video. To calculate delay, here we have two methods. One is using resistors and one is using timers. In this video, we'll be covering about calculating delays using resistors. The calculating delay using resistors is hardly used because we have good amount of timers available in 8051, but still let's get covered up this topic. So here, yes, it's important to note that you understand this code. In the you can see from line number 3 we are moving hexamal value 55H to A. Its binary form has been shown in the comment section. Again in the fourth instruction we are moving move P1 comma A. So this loads the port 1 with A. If you don't know what are ports, please be patient. Like we'll be covering what are ports in the upcoming videos, but still just assume that there's something as an external port over there on which we are moving 55H. Then we are in the fifth instruction, we are calling for delay. A called delay. So this instruction calls for delay and it jumps to here because these are known as labels. So the delay label is over here. So from the 9th instruction we know that it will move 200, a random number in R3. Remember here I have not mentioned H after 200, so it will be a decimal number. So I am moving 200 in R3. So this instruction of moving 200 in R3 takes one machine cycle. So I have one machine cycle. Then we have DJNZ R3 comma here, that is decrement R3 and jump if it's not 0. So from 200 it will decrement to 199 and check whether it is not 0. So it is not 0, so it will jump to here. Here is the same instruction. Again it will jump over here. So so the DJNZ instruction takes, as I was saying, the DJNZ instruction takes for around 2 machine cycles. So the 10th instruction of DJNZ will be it will be running for 200 times. I hope you understand why it will be running for 200 times. So basically 400 machine cycles would be wasted in the 10th instruction because one instruction takes 2 machine cycles and it will be running for 200 times. So 400 machine cycles would be wasted. I hope it's clear. In the 9th instruction, as the 9th instruction would be running just for once, so around 1 machine cycle would be wasted in that. So in total 401 machine cycles have been wasted. In the next instruction is return. Return takes 2 instruction cycles. Yes, I'm right, I guess. Return takes 2 machine cycles. So 401 plus 2, that is 403 machine cycles have been wasted in 9th, 10th and 12th step. So 403 into 1.085 microseconds gives 436.255 microseconds. So let's take a even number as 436 microseconds. So for about 436 microseconds, the port 1, this port 1 I am talking about, you can see the cursor, this port 1 I am talking about. This port 1 will be having values 55H for 436 seconds. After this it calls for return, so return goes over here, complement A. It will complement A, that is 0 will become 1 and 1 will become 0. So the number which will be formed is 10101010 in binary, right? So A will be complemented and SJMP again is short jump again, so it will again jump over here, move P1 to A, that is the complement version of 55H will be moved to A called delay. Again it will call the delay will go to 9th step. In the 9th, 10th and 12th step, again for 436 microseconds, to be precise it's 436.255, but let's just say for 436 microseconds the port 1 will have the complemented value of 55. So the complement value of 55H, that is AAH, would be there for 436 seconds. Again after executing after 436 microseconds, the return instruction would take back the pointer to CPLA. So again the AAH will get converted to 55H and 55H will again be moved to port 1 after execution of SJMP again. So P1 would be 55H would be moved in P1. Then it calls for ACALL delay. ACALL delay makes it jump at the 9th step. At the 9th step again 436 microsecond it will wait, and then again it will complement. So basically high low condition would be executed. Let's check its execution, how it is executed. Click it on here. I've already compiled the code, so I guess I don't need to compile it again. Let's check it on this and setup has been already done by me. In the later videos I'll teach you how to set it up again, don't worry about that. Yeah, so I'll just zoom out. Yeah, as you can see the high low condition would be going, and the distance, that is the time period, is 436.255 microseconds between this and this. So that was the first method of calculating a delay. The second method will be shown to you in the next video. Thank you.